In this video, we will talk about sign diagrams. Sometimes we don't want to draw a time-consuming graph of a function, but we want to know where the function is positive, negative, 0, or undefined. Sign diagram is basically used to represent where the function is positive, negative, undefined, or 0, as we talked about. So how do we do it? Where it has the 0, in other words, where the y value is a 0, those are at -2 and 3. We're going to write a tick mark and -2, a mark, and a 3. Where it has the asymptote, in this case at 1, we're going to create a dotted line, representing that this is a asymptote. Now, we're almost there. Where the value is smaller than -2, has a y values that are less than 0. So it's going to be negative. In between -2 and an asymptote of 1, value of y is positive. So that's going to be plus. In between 1 and 3, y values are negative, so minus. And right side of 3 is all positive, so it's going to be plus. For each of these graphs, draw a sign diagram. First, we want to create a number line x. Where it crosses the x-axis or where my y values are equal to 0. So those are -2, 1, and 4. On the left side of -2, all of my y values are below the x-axis, so it's negative. In between 2 and 1, it's above the x-axis, so y values are positive. Same logic over here, it's going to be negative, and at over the 4, on the right side of 4, it's going to be positive. Alright, let's continue with the problem on the right side. First, create a number line, x, and then where it has this arrow and a half, that means if we were to zoom in this a little bit, it's passing the x-axis at 1/2. That 0 is 1/2. Although it looks like it's passing through the origin, that's what the textbook does. On an actual IB problems, it'll be much more clear, and so does on my quizzes and test. Okay, so zeros are happening at positive half. And is there anything else? No. But we do have two asymptotes at x equal to -2 and when x is equal to 3. Then observe what the y values are. Here, it's above the x-axis, so it's going to be positive. In between -2 and that 0 of 1/2, it's going to be negative. Then it's positive, then it's negative. Draw a sign diagram of each of this graph. First, we are given that y is equal to x plus 3 and x minus 2. Yes, we can FOIL this and then graph by using a xy table, but we could also do where it's passing through the zeros. Obviously, at x equal to -3 and at 1, those are my zeros. So create a number line of x, and then at -3 and 1, those are going to be our zeros. We just want to know the y value, whether it's negative or positive. So plug in a number that's less than 3, or -3, such as when x is equal to -4. We have -4 plus 3, that's -1, times -4 minus 1, that's -5. So that returns the value of positive 5. So positive. In between -3 and 1, always the easy one is a 0. So when we plug in x equal to 0, we have 3 times -1, so that's going to be negative. And for when it's anything greater than 1, such as 2. When x is equal to 2, we have positive times positive, so that's going to be positive. Again, we're not so much interested in what the actual value is, but whether the sign of the y value. Okay, so if we wanted to FOIL this, say, this x plus 3 and x minus 1, we know that we get x squared, 3x minus x, that makes it positive 2x, negative 3. This has an a value of 1, so it's concaved up. So it's positive, so it's going to be above, below, and above. And this just confirms that this function is concaved up. Alright, for the problem on the right side, we have the zeros happening at x is equal to negative 5 over 2 and x equals to 3. So create a number line of x and then plug in negative 5 over 2 and 3. Plug in a number that is smaller than negative 5 over 2, such as x equals to negative 10. If we plug in negative 10 for all of the x's, we get 2 times some kind of negative number times a positive number, so that gives us negative. In between negative 5 over 2 and 3 would be 0. So if we plug in 0, it becomes 2 times 5 times 3. That's some kind of positive number. And then what about x equals to something greater than 3, so positive 10. That gives us 2 times some kind of positive number. 3 minus 10, that's a negative number, so this will be negative. Alright. Based on the sign diagram, we know on the left side of 5 over 2, y value is negative. And then it passes through the 0, right? And then it's positive, y value, 0, and negative again. So this is a concaved down function. See if you get a concaved down, for example, a is less than 0 function when you FOIL this. More sign diagrams. Alright, so here we're given y is equal to 12 minus 3x squared. Well, we notice that there is a common factor, so we can pull out the 3 and make it 4 minus x squared. Let's find the zeros of this. So 4 minus x squared is equal to 0. So that tells us 4 is equal to x squared. Therefore, x has to be plus minus 2. So draw a number line, 4 minus 2 and 2. And then plug in the numbers to see whether y value is negative or positive. So on the left side of negative 2, so such as x equals to negative 3, if I plug in negative 3 on here, since it's already factored, it's nice to easier to calculate. We have negative 3 squared, that makes it positive 9, but we have 4 minus 9, so that's a negative. In between negative 2 and 2, such as a 0, we have 3 times 4, that's a positive. And something greater than 2, such as x equal to 5. 5 squared is 25. 4 minus 25 is a negative number, so positive times negative is negative. So this graph will be concaved down. And if you look at the original function, yes, it is concaved down because of this negative 3. Alright, continue. Y is equal to negative 4 times x minus 3 squared. Alright, let's find out where the zeros are. So negative 4 x minus 3 squared is equal to 0. Obviously, it's going to be x minus 3 squared is going to be 0. And then we have a square root on both sides, so x minus 3 is equal to 0. So x equals to 3 would be where my 0 will be. So create a number line, plug the 3 in, then test the values. Something that's left side of 3, such as a 0, if you plug in the 0, we have 0 minus 3, that's negative 3. But we need to square that number so it becomes a positive. Negative 4 times some kind of positive number, that's going to be a negative. What about something that's the right side of 3, such as 5? 5 minus 3 is 2. 2 squared is 4. 4 times negative 4, that's another negative. So we have negative and negative. In this case, we have a y value that's negative, and then 0 at 3, and then a negative. So it's the case where the graph is going to be touching the x-axis at 3, but it'll be concaved down. Foil this and see that's what you get. Last question on this video. When we have a fraction that's a 0 over some kind of number 3, this is equal to 0. However, when you have a 0 on the denominator, 3 over 0, this is where it's undefined. So using that logic, when numerator goes to 0, that's when x minus 1 is equal to 0. So when x is equal to 1, that's where my 0 on this function is going to be. When the denominator goes to 0, 2x plus 1 is equal to 0. So x is equal to negative 1 over 2. That's where it's undefined. In other words, that's where the asymptote is. So let's draw a number line at negative 1/2. That's where the asymptote is. So it needs to be a dotted line. And then at x equal to 1, that's where my 0 is. So plug in a number that's smaller than negative 1 over 2, such as negative 10. Negative 10 minus 1, that makes it negative 11. Negative 10 times 2 is negative 20, plus 1, negative 19. So that gives us a positive number. In between negative 1/2 and 1 is a 0. So when we plug in x equal to 0, gives us a negative number. When x is 10, we have 9 over 21, so that's a positive number. So the sign diagram of this function will be asymptote at negative 1 over 2, and the signs are positive, negative, and positive.